Okay, here is another problem. In this one, we are given a situation where we have a transformer which is used to charge batteries. They ask us, what is the voltage output? The output. So this means we are interested in the voltage on the secondary side of the transformer. We're looking for V sub S. So the output of the transformer, the voltage, is going to be V sub S. But then we're told something about the transformer. We're told that its properties is that it has 500 windings or 500 turns on the primary side. So NS is equals to N sub S in this case is equals to 500. And NP is equal to 500. While NS, we're told here, the secondary side has 4 turns. Now, remember, transformers must be attached to a source. They must be attached. They don't have electricity of their own. They don't generate electricity. They're passive components. So they receive a signal of AC, and then they would affect it accordingly, either step it up or step it down. Here we're told that our transformer is attached or connected to an input voltage of 120 volts. That is V sub P is equals to 120 volts. And they've asked us to find what is its output. Well, just from looking at the turns, notice the primary side has 500 turns, whilst the secondary side has 4. We can already figure out what type of a transformer this is. Remember, we characterize a transformer using the turns ratio, that is NS divided by NP. If this ratio is larger than 1, our transformer is a step up. If it's less than 1, it's a less than 1 yet positive, it's a step down. If it's equal to 1, that means our transformer is an isolator transformer. It serves to isolate typically 2 sides of a circuit. So if one side shorts out, the other side is safe. Typically it's used for safety reasons to prevent any fluctuations, shorting. So anyway, the point is, before even attempting the problem, we can already expect that the output voltage must be less than the input because of the characteristics of this transformer. Its turns ratio take this form. And clearly this value is much less than 1. It's positive, but less than 1. So we expect that this transformer is going to be a step down transformer. Now let's confirm this. Well, from our law, this is part A. From the law of voltages with relation to transformers, that law is given by this. Over here, I've flipped around the order. Typically, I write primary on the left and secondary on the right, but here I'm kind of thinking ahead. So this is what this is going to look like when we make V sub S the subject of the formula. We end up with NS. That is the secondary side, the number of turns in the secondary times the number divided by the number of turns in the primary. Multiply that by the voltage on the primary. This is going to be 4 because that's the number of turns on the secondary, divided by 500, number of turns on the primary, multiply by the input, which is 120 volts. You're welcome to, again, find the exact value here. But as you can see, we're multiplying 120 by a number that's less than 1. We know the outcome is going to be less than 120. We're rescaling it. Okay. Then part B goes on and says, what is the current? What is the current required to produce an output of 4 amperes? Well, This time around, they tell us that the output current, in other words, the current on the secondary side is, or the desired, the target, is 4.0 amperes. They ask us what must be the initial, the input, or the primary. Well, we know again from the law of transformers related as far as currents are concerned, it is given by this. We do know the number of turns on the primary, the number of turns on the secondary. We have a target output voltage, output current. Now we'd like to find what must the input be in order to achieve this output for this particular transformer with these number of turns, both on the primary and the secondary. Well, then that means I sub P is going to be NS over NP multiplied by IS. Now, as you notice, the number of turns on the secondary side, that is going to be 4, and the number of turns on the primary is 500, multiplied by the current on the secondary side, which is 4 also. Oh, that's interesting. Coincidentally, okay. Then we end up with 16 over 500 amperes. So as you will see again, that if you're welcome to check this out, this number here is less than 4. Is less than 4 amperes. This number here. Again, as we said, this is a step-down transformer. It has reduced the voltage from 120 to some new number, which we can determine here, or which we have determined here, but not the decimal numerical value of it. But the point is, this transformer steps down the voltage, and the output of its current is larger than its input. So while it reduces, hence transforms, the amplitude of the voltage from a large number to a small number, with the current, it increases it from a small number to a large number. So step-down transformers, again, I would like to emphasize, we're not making energy or getting voltages out of nowhere. It's always a trade-off. When we step down voltage, it means we're amplifying current. When we step up voltage, it means we are reducing the current. Okay, I will stop here for, we have part C. Now part C, they say, what is the power input? Well, electrical power, the definition of electrical power, let's go to C. The definition of electrical power is equals to the current times the voltage. Well, now we're interested in the output, so we're going to say power out. Well, the output here is the same as the secondary, so we have the secondary. Well, we know what our current or our target current is on the secondary side. It's 4 amperes. But what about the voltage? The voltage we already have determined over here, so we can punch that in and determine it. So this is going to be 4 times 4 over 500 times 120. This will give us something like 16 times 120 divided by 500 volts. Again, you're welcome to get the numerical value, the decimal numerical value. But this is all I'm trying to convey is how to approach problems and how to navigate these input and outputs so that we don't confuse them. Okay, so if you still have issues or you're struggling to confirm your values, you're welcome to mail me, but I will stop here with this problem and I'll see you in the next one.